Hello students, in this session we are going to understand a little bit more about Python programming language itself. So we will be hovering around a few major topics and few major packages that are very well useful in Python. One is NumPy and pandas and matplotlib. Okay, so these are the three different packages that we are going to see, and there are so many useful functions inside all these packages, and we will see how it can be used in our artificial intelligence course itself. So these are all the LOs which we have, and the first thing which we need to understand is what is this NumPy. Okay, so the word NumPy itself just gets you understand uh, that it is numerical Python. Okay, it's a numerical Python, and it's a very powerful Python library, and mainly used for all the numerical statistical calculations and the scientific computing and everything. And NumPy is very effective, and it can work with large and multi-dimensional arrays, and it's very fast. So whatever be it, whether be it a very complex mathematical operation or very large data that you are dealing with, doesn't matter, NumPy can work in a very faster way. And so why is it so? Because NumPy actually has got something called as n-dimensional array objects. It is basically called as ndarray. Okay, and it is actually multi-dimensional. That means that it can actually store data which are multi-dimensional, and homogeneous collection of items stored in contiguous memory locations. It's normally like your array itself, but not like your Python list. It cannot actually store heterogeneous data and store, or something as pointers and all you cannot store, but at the same time you can actually store homogeneous collection of data, but even if it is multi-dimensional, doesn't matter. And there is a concept called broadcasting mechanism. Okay, and this broadcasting mechanism is very powerful. Why? Because it helps you to perform the arithmetic on all these arrays of different shapes without explicit looping. That means that you can do lot of operations upon even the array sizes are different. Okay, so you can do all the arithmetic operations upon this array. So normally when we do all these arithmetic operations on the array, all the array sizes has to be similar, but here it doesn't matter. So broadcasting is one very powerful mechanism in NumPy, which can actually be applied upon complex mathematical operations. And the next one is basically vectorized operations. So vectorized operations means anything and everything is actually considered as vectors. So what do you mean by that? That means that you can actually do element wise operation. Say you have a big array, you have two different big arrays, but upon when you are actually adding, or when you are performing some arithmetic operations on such arrays, you can actually do element wise calculations or operations. And what happens by that way is that it will speed up the computations when compared to the Python loops. A normal loop will traverse through each and every element in your array, right? So that takes more time. So time consumption is more in the normal Python loops, but when you are actually working on the vectorized operations, the time consumption is actually, or the computational resources that is actually required for all these operations are actually lesser. And when you look into this vectorized operations, this is the main key when you look into any of your deep learning algorithms or natural language processing based algorithms. Vectorized operations is a must. So this is a very effective concept which is there in the NumPy. And the last one is basically integration. That means that this NumPy can be integrated with any high level libraries which are available in Python, like SciPy, Pandas, scikit-learn. All these are the powerful packages which are there in Python, and with all these packages you can actually integrate this NumPy so that it makes your life easier when it comes to complex mathematical operations. So you don't have to worry much about how the complex mathematical operations could be done. Why? Because Python actually provides you a very effective library, okay, called NumPy. Now, why do we actually go for NumPy, or what is that makes NumPy so efficient? So it's speed of operation, so better than the Python lists, and handles large data sets easily. The functionality, there are so many inbuilt functions which can be used for statistics, linear algebra, and random numbers. These are the major operations that you might be dealing with any of this in any of these algorithms. And convenience, that means vectorization and broadcasting is possible, so you don't need explicit loops to take care of all these operations. And compatibility, works well with all the different high level packages like pandas, matplotlib and scikit-learn, etc. Now, understanding NumPy dimension. So we were talking about, it can deal with multi-dimensional data. So what do you mean by multi-dimensional data? So normally we have seen that we have actually worked with 1D array, right? Like 7, 2, 9, 10. I mean, like this is a one-dimensional array and which is having a shape of 4. When you look at this is a 2D array. So that means that it has two different dimensions, right? So it has two dimensions, so 2 by 3 in fact, right? So 3 columns and 2 rows. And when you look at this is actually 3-dimensional. So it has got 4, okay? It has got 4 and then 3 and 2. So 1, 2, 3, 4, and again you have 3 and you have 2. So it's actually 4 by 3 by 2. So x, y and z dimensions, right? So this is, so such kind of data can be easily dealt with NumPy dimensions, and they are called as the ndim. Dim is for the dimension. Now coming back here to how are you going to create a NumPy array, okay? So how are you going to do that? So normally with the Python list, we have already seen that in the last class, okay? So import NumPy as NP. So as operator, you already know this is nothing but you are renaming your NumPy as NP, right? So you are actually creating an array. Array is nothing but np.array, right? 1, 2, 3, 4, 5, and you are simply printing the array and you are printing the shape of the array, right? And here it is basically, you are using arrange operation. So its function, so np.arrange of 0, 20. So it will start with 0. It will start with 0, right? And it will stop before 20, and it will also taking a step of 2 at a time. So now to have a understanding about it, okay, let's take this let's take this one. So this is from the, so this is exactly what we are actually seeing here. So this is what we are actually working upon, okay? So from the existing Python library itself, sorry, list itself. So here you are importing in NumPy as NP, and you have an array which is 1, 2, 3, 4, 5, and what will happen? So when you run this, what is it happening? So it simply prints your array. So 1, 2, 3, 4, 5 is actually printed, and array ARR is the array name, okay? Dot shape means it will simply give you the shape of the array. So when you look at it, it is a one-dimensional array, so just 5, right? And this arrange also we have seen before. So SEQ is given as 0, 20 and 2. So it has to take a step of 2, and it has to go until 20. That means 20, you cannot take 20, it will stop before 20, and it will traverse through all the numbers within 20, and it will take 2 steps. So that means that it will kind of print the even numbers, right? So 0, 2, 4, 6, 8, 10, 12, 14, up to 18 will be printed because next number is 20, right? So this is what we are actually seeing here. Now going back here, so you're creating the NumPy arrays, okay? And you can also create the NumPy array with zeros, okay? I don't want anything in my array. I just want arrays which have zeros initially, and then later as time goes I will fill it in. So for that you can actually use np.zeros, okay? So zeros is the one which you have to use, and what is the dimension that you require for your array? So 3 rows and 4 columns. And ones, if you want ones, you can actually fill it up with by using dot ones, okay? So this is actually possible. And there is something called linspace. So linspace is something like your line space only, but you want it actually evenly spaced points. So that means that, say you have 5 points, I want 5 points. So this is actually the count, 5 points, and I want all the points between 0 and 1, and which has to be evenly placed. And understand here 0 and the 1 are inclusive, okay? So it has to be printed along with it. So when you go back here and see, sorry for this, when you go back here and see, you will understand that you are creating. So we will see the first example. So creating arrays filled with zeros and ones. So for that you have np.zeros. So when you print here, you are getting an array which is actually of the dimension 3 by 4 and it is all filled with zeros, right? And again you are actually building an array which is actually filled 2 by 2 array. So this is a 2 by 2 array and this is actually filled with 1. Okay, so then there is something called num space. So you have start and stop and whatever be it, you know. So by default value is actually 50. So default what is that, what do you meant by that? You need to have that, you know, the even space that has to be filled has to be 50, but you can also provide the values here, that is also possible. So 5 points between 0 and 1, okay, which is evenly spaced. So 0, 0 0.25, 0 0.5, 0 0.75, 1, right? They are evenly spaced and they are between 0 and 1, and 0 and 1 are inclusive, right? So when you look at it, you have this here. So linspace 0, 1 and 5. So 5 is the kind of the space that you require and the number of the elements that you require, and you need this between 0 and 1, inclusive of 0 and 1, right? And that is actually placed here. So this is one example which you got. So these are all the various methods you can or you need to understand and you need to be careful about and understandable about, so that it will be useful for you. Now the next one is actually NumPy array methods. So NumPy array methods means you already know how the NumPy array can be created. Now what are the different type of methods that can be applied upon this NumPy array methods? This is the first set. So you're actually creating a matrix. Okay, it's a NumPy array of two different 1 2 3 and 4 5 6. Okay, you're creating an array and you are applying the shape, you are applying the size, dimensions, data type, all those things you are trying to print. And this in 64 and 32 is nothing but it depends upon your system configuration, right? Whether it is 64-bit or 32-bit system that you are actually using. So when you look at it here, you are actually creating an array. Okay, this is the array that you are creating. Its name is actually matrix, right? And matrix dot shape. What is the shape of the array? So the shape of the array, if you could see, there are 2 rows, right? And 3 columns. So 2 by 3. Okay, and the size of the array is 2 by 3, so 2 into 3 6, and there are 2 dimensions x and y, and according to mine is a 64-bit system, so it actually gives me 64, right? And now let's see and move and see a little bit more about the various methods that can be applied. There are so many methods which are available. So these are all the inbuilt mathematical methods which you have. So you are again creating an array. Okay, sorry, you are again creating an array and you are applying sum, mean, minimum value, maximum value, index of maximum, minimum, cumulative sum, etc. So all these are default ones. So cumulative sum gives a cumulative sum of all the elements, and argmax, so the index of max is argmax. Argmax means it is like the mode. Okay, whichever is the largest one, that will be actually given to you. Argmin returns as index of the smallest element, max returns the largest element and smallest element. So you will get to understand the difference between this argmin and argmax and min and max in a little bit of time, but this is the element and this is actually the index. So argmin and argmax is basically gives you return the index. Okay, so when you look at here how it is actually run, you will understand this. Say you have this array and in this array you are just printing the array, that is what is actually happened here, and you are actually finding the sum, which is arr dot sum. It simply gives you 150 and mean is nothing but 30 and minimum value is 10 in this array, right? And maximum value is 50 in this array, and index of the minimum value is 0, index of the maximum value is 4, and this is the cumulative sum. Cumulative sum is nothing but, say initially you are starting with 10, then 10 plus 20 is 30, then again you are actually 30 plus 30 is actually 60, and 60 plus 40 is 100, and 150 is 150, right? This is how it is actually finding the cumulative sum. So hope you understand that. Now coming back to the next operation which we have, which is actually very powerful operation, and we have seen a little bit about it beforehand itself, that is indexing and slicing. So indexing and slicing the 1D array, right? So that is what we are actually seeing the first time. So indexing and slicing the NumPy 1D array. So this is your NumPy 1D array, and when you are actually creating an array here, and actually you are indexing the array. So this is exactly like how we actually index or call a particular element within an array in the normal way. So ARR of 0, it gives you the 10. ARR of -1, it gives you 50. Why? Because Python has got reverse indexing, right? What is the meaning of this -1? -1, say here it starts from, say if you are going for a normal indexing, you will go for 0, 1, 2, 3 and 4. If you are going for the negative indexing, -1, -2, -3, it goes like that. So when you do this particular example, you can actually make your hands dirty a little bit more and tweak a little bit and see how everything works. Now we will also see slicing and then go back to the Google Colab. So slicing, here what happens is that you are slicing. So slicing normally has got three things. So start, end and the step, right? So where are you starting the slicing from and how are you actually slicing it? So 1 to 4. So 0, 1, 2, 3, 4, right? So 1 to 4 means it will have 3 elements. So if you are starting from 20, 30 and 40, right? 0, 1, 2, 3, so it is 4, right? So this is actually nothing but the slicing. Now if you are simply giving without giving the first value, then it will start from the 0th element itself. So what happens? So you will get 0, 1 and 2. So 10, 20 and 30. And what about this one? This is actually the step. Understand, there are 2 colons here and then followed by 2, right? So what are you doing? You are actually trying to get the second element. You're skipping one element and jumping to the first element. So you will start, as you have not given anything in the first one and the second one, it goes through the complete list. But how will it actually take the elements? It will take the first element, then it will 2 steps it will jump and take the second element, then 2 elements it will skip and take the sixth element. It just goes like that. So 10, then goes to 30, then goes to 50, right? So every second element will be actually printed, right? Now let's see how it works in the Google Colab. So when you look at it, you have the array and you are trying to print the array, okay? And when you look at it, you are getting the first element and the last element. Last element is for this -1, right? Then when you are printing this 1 to 4, okay, how are you getting all these values? You have it here, right? So this one you can actually try the same thing. You can actually do it. Say this, we have actually seen it in the last class. Say if you want to reverse your array and if you want to print it, this is the easiest way. Colon, colon and -1. It actually reverses the array. Now these are all you can actually just try and tweak. So you are starting from the last element and you are jumping 2 elements at a time from the reverse indexing. So 50, 30 and 10. If it is -3, it will take 50 and 20. It will jump third element, right, in the reverse order, and it has got only these elements when it jumps three times, Third time when it jumps, it goes out of the array. So this is all about, this is about indexing and slicing, which is very, very important. Again, a little bit more indexing and slicing is given here. So here you were actually talking about the indexing and the slicing in the 1D array. And in the same way, you can perform the indexing and slicing upon 2D or 3D array. That means multi-dimensional arrays. That is also possible. So you are just creating a multi-dimensional array here. That is 1, 2, 3, 4, 5, 6. See, you are actually printing 0, 2. So what happens? 0 and 2. So you are actually getting the first row, right, and the third column. Okay, third column. So whatever be the value that you will get. So here if you simply give colon and 1, what does it mean? It will actually give you all the rows but the second column alone. Okay, so second column alone here is, what are the values? 2 and 5, right? Now when you are looking at the matrix here and you are giving the first one, but what are you doing? You are actually not specifically telling anything about the ending, right? So what are you getting? You are actually getting the 0 and 1, right? So you are getting 4, 5, 6. So that means the second row, all the column, okay, will be gotten for you. So now when you try to apply this, you will understand this way. So there are so many things, you can actually learn out from this. You can actually try a lot and then find out and get if you have any small confusions, try it out, make mistakes and then learn. Okay, so when you look at it, you are getting the 0 and 2. That means first row, the third column, first row, third column, first row and the third column. So you're getting 3. So like that you can try to get access all the things, and you can try to get access from the reverse direction, and all those things can be done. Now going back here, again indexing and slicing, you can also perform that with the help of the Boolean indexing. So what do you mean by Boolean indexing? So you are actually creating an array like this, okay, and in that array you want the elements which is greater than 3, right? So how would you do? This is the whole array, and in that you are actually, so here the indexing itself is a Boolean indexing. What do you mean by that? You will take only those elements which are actually greater than 3. Okay, if it is greater than 3, you are there. So it's a Boolean value. If it is greater than 3, you are there. Otherwise, you will not be there. Okay. So this is nothing but Boolean indexing. So when you look at here, okay, this is how you will do it. Okay. So when you perform it, you will get a simple answer, which is nothing but here the condition is met. Whichever values actually meets the condition, only that would be printed. Okay. And this is again the same thing only. I have just repeated it. That's all. So basically this happens like this. So I just wanted to show you like how it actually works. So it actually creates, see, this is your whole array. This is your array greater than 3, right? So your whole array will be checked against 3, right? So 1 greater than 3. 1 greater than 3, is 1 greater than 3? No. So it will create a false. 2 greater than 3, is 2 greater than 3? No. 3 greater than 3, I have always told you 3 greater than 3 is false. 3 greater than equal to 3, then it is true. Okay. So here what are we checking? We have only greater than. So 3 greater than 3, again it is false. 4 greater than 3, yes, it is true. 5 greater than 3, it is true. So what happens? So this array of ARR greater than 3, it selects only those values which are true. Okay. So what all values will be picked up? 4 and 5 will be picked up, and that is actually given to you as the output. So this is nothing but Boolean indexing. So this is very, very important concept, and it is a very powerful concept which you will be using very commonly across deep learning and machine learning algorithms. Now coming back to another beautiful concept of a NumPy, which is nothing but broadcasting, right? So broadcasting allows NumPy to perform arithmetic operations between arrays of different shapes. Okay. So what do you mean by that? You have an array. See here, you have an array np.array. This is actually 2 by 3 matrix, and this is a one-dimensional matrix, and you are performing some arithmetic operation of a plus b. Okay. So is that actually possible? Okay. So 11, it will give you 22, it will give you 33, then it will give you 14, then it will give you 25, then 36. This is the values which you want, right? But in normal cases, normally we won't be able to do such kind of operations with different dimensions, but here it is actually possible. So broadcasting is basically a important technique. So instead of manually replicating the data, NumPy automatically stretches smaller array to match the shape of the larger array. So how is it actually done? Okay. So it is actually done. So this is the larger array and this is the shorter array. Okay, smaller array. So it actually, the smaller array is actually mapped down to the larger array size, and it does the mapping. But is it using, so memory consumption is done? No, memory consumption is not or is lesser, or it is not having any extra memory usage. So that makes this more efficient. So this calculations will be faster and more memory efficient. That's the main plus point of this. Then the rules of broadcasting. So if the arrays have different number of dimensions, the smaller array is padded with ones on to the left. Okay, and the dimensions are compared element wise. If the size matches, they are compatible. If one of the dimension is 1, it can be stretched. If the dimensions differ, neither is 1, broadcasting fails. So if the dimensions differ and if it is not 1, which is not padding values are not 1, then what happens? This operations cannot be performed. But do you have to really worry about it? No, you don't have to worry about it because it is taken care internally. Okay. So now comes the vectorized operation. So just understand about how the broadcasting works. And then comes the vectorized operations. So in vectorized operations, so when you look at it, sorry, I forgot to talk to you about the step-by-step broadcasting. So say the shape of the first array is actually 2 by 3 and the shape of the second array is basically 3, right? So what happens is that NumPy treats this 1 3, it treats this as 1 3, okay, by pretending 1 as the missing dimension. So when you look at this explanation here, okay, if the array has different dimensions, the small array is actually padded with 1 on the left, right? And then the dimensions are compared element wise. If the size matches, they are compatible. If one of the dimension is 1, it can be stretched, right? So this is what is actually followed. So when you compare from left to right, what happens is that the dimension 3 is 3, it is compatible, and then again 1 against 2, so again there is a 1, so that is also compatible. So this is that condition which will actually check for the broadcasting, right? So here actually it will look like 2 3 and 1 3, so both of them are actually compatible. And now what happens, so it will broadcast. So what do you mean by broadcasting? Broadcasting means it will just repeat it again once again, okay, and now it's like a normal addition. So 1 plus 10 is 11 and 2 plus 20 is actually 22, and it just goes like that, right? And you will get the answers, specifically. It's a normal addition. After that, it's matrix addition, that's all, okay. So you will get your answer. This is nothing but the broadcasting in a detailed manner, okay. So but if you are actually not padding with 1, but if it is some other element, instead of 1 3, if it is actually something else, this whole broadcasting will not happen, it will not work, okay, it will not work. That's all is the concept of broadcasting. Now when you look at the vectorized operation, so again vectorized operations it actually performs on the entire arrays at once. This is very important line. Vectorized operations, vectorization actually performs operations on entire arrays all at once instead of using explicit Python loops. So NumPy actually applies operations element wise automatically on the arrays. Use of vectorization makes code faster, cleaner and more efficient. So this is the major concept behind vectorization. Say you have an array 1 2 3 and you have another array 4 5 6. So if you want to perform x plus y, okay, what happens is that it applies upon all the this operation is applied upon the entire arrays all at once, okay. So what happens is that 5 7 6 is it's just one operation, okay. X into y, it's just one operation, and x star stars 2, it's a single operation. So just wanted to show you this vectorization. What happens is that, see, it actually what is the meaning of vectorization is applied upon the arrays all at once. Say there are two arrays, right? So it is applied upon one operation. So it's applied like one by one. So 1 plus 4 is taken, 2 plus 5 is taken, 3 plus 6 is taken, right, all together, right? So this is what you have to identify here, right? So here it is actually 2 into 5. 1 second, so don't get confused. Here it is actually 2 into 5. So maybe a space is required here just for the sake of showing it, okay. So 2 into 5, right? So these are the operations that will be actually performed all at once. So here, instead of writing a loop to process each element, operations are applied upon the entire array all at once. And there is a small example actually which is actually given here. If you want, you can actually say for I is equal to range. How it is done, this is the loop way and this is the NumPy way, right? So this is something which you have to keep in mind. So summarization, vectorization basically means writing operations on whole arrays, okay, and letting NumPy handle the looping internally in the optimized code. So NumPy is actually applied. It is you are applying all this numerical operations, but upon what? Upon an optimized code. What is optimized code in vectorization? You are taking both elements from both the arrays all at once. So that is optimization which is actually happening here, right? And now going back to so this is all about your vectorized operation. Then again, so this is NumPy random number generation. There are so many random number generation functions, okay, because I mean, like, so many are there and they are all used for various operations. And sometimes you will have to generate even a random data set, okay. Even for that you can use this random. So this rand functions you can very commonly see in all this deep learning, and because sometimes we will have to generate something called filters, so we will use random number generator. So all these things are actually done in various ways. So random functions are very important and very efficient in in the artificial intelligence. So pseudo random number generations, for it could be for randomized algorithms or sampling the data or simulations. It could be for any functions, Okay, so you can also generate 2D arrays and 3D array of random numbers. Anything and everything is possible. Okay, so now this is the first one. So I will just go through this slides, and then we will go and see the examples. So np.random.rand, okay, rand, okay, random numbers in 0 and 1. So generate samples of the uniform distribution. So how the data is generated is actually very, very important. So if you want a uniform distribution which actually hovers over 0 and 1, then you can go with this. So generate scalars and array of random float. So generate a single random float between 0 and 1. So what is that? It is actually simply generating some random numbers. Okay, so a random number which is a float value, okay, between 0 and 1. So this is just, if you are actually applying np.random.rand, it is generating just this red colored one, only one. Okay, now what is the next one which you are doing? You are actually generating, I want random floats, but I want an array. What kind of an array? 2 by 3 array, right? So where am I giving it in the function, this np.random.rand? Inside the parameter list. Inside the parameter list, if I give the values 2 comma 3, what is happening? It actually generates the random floats, and it will be in the format 2 rows and 3 columns. So if you see here, 1 2 3 3 columns, 1 2 3 columns, and 2 rows are there, right? So 2 by 3 matrix will be generated, and all the values within the each time when you run, this values will be changed. Okay, so that's the beauty of this np.random.rand. So you can also give them within a particular range or within a particular size. If you want, you can do that as well. Now then, this is actually rand, right? Now I want random integers. So if you are simply giving rand, what kind of values will be generated? Float values will be generated, right? Now what I want is, I want some random integers. Okay, I want you to generate the low and the high. I want to generate it as random integers. Okay, so what will I do? Say the same thing, no problem. So random integer between 0 and 9, okay, inclusive of 0 and inclusive of 10, exclusive of 10. Okay, so it is between 0 and 9. So these are all very important, and could be some questions which you can get for your first MCQ quiz, the midterm examination, okay, which is MCQ. So when you look at it, it is np.random.randint of 10. So randomly it will generate, okay, randomly it will generate some value, one value within this range. Between 0 to 7, one value will be generated. Okay, now see here, I want a 2 by 3 array. So how am I giving? See here, this is the way. So low, high. So between 1 and 7, it could be 1 and 7 also, and it will be exclusive of 7 but inclusive of 1, right? And then what is it? The size. I am giving the size, right? I am specifically, this is the syntax for it. Okay, this is the syntax for it. And low, high, size. So what is the size? Size should be, it should be a 2 by 3 array. So I'll give like that. So when you look at the array, you will not have the value 7. Okay, you will not have the value 7. Why? Because I have given the upper size as 7, and you here I have clearly mentioned that inclusive of 0. Say if my range is 0 to 7, then it will be inclusive of 0 but exclusive of 7, right? So that is exactly what has happened. Now this is very, very commonly seen. Okay, set the seed for NumPy's random number generator, ensuring repeatable and deterministic results. Okay, so it is very important for debugging, testing, and scientific experiments where reproducibility is required. Say you might be generating, say when you generate with a random number, what happens every time when it generates, each and every new numbers will be generated. But here, if you are actually giving as a seed, okay, it almost generates within a particular range, so that what happens, you can reproduce or rerun your experiment and you will almost get the similar results, right? So that is the beauty of the seed. So the seed, random.seed, you will be able to see it very commonly in deep learning algorithms. So when you look at it, how would you do that? np.random.seed of 42. So you are setting the seed as 42. Okay, so np.random.rand of 3. Okay, and here np.random.rand int 0, 10, and size equal to 3. Okay, so initially itself, what are you doing? You are actually setting the seed as 42. So seed actually gives you, make sure that you can actually reproduce the results. So say if you are not setting the seed, you can get random numbers generated, but if you are setting the seed, you will get the output as similar as possible in every run. Sometimes in ML algorithms and deep learning algorithms, this is actually required to identify and understand the efficiency of your algorithm itself. Okay, so this is very important for that. And now the next one, yes, it is Panda. So I will just go back here and let's run this random. Okay, so now when you are actually running the random, it will randomly generate one particular number here, as we have seen, right? This is the output for this one. And if you're generating 2 3, it is actually giving I want 2 by 3 array. So here if you could see, you generates 2 by 3 array exactly as we see. Then rand int is for random integers, right? So if you are actually giving back here, it just gives you any number between 0, but it is exclusive of 10. Okay, so that's also between 0 and 9. And here it is 1 to 6 you are giving. So say 1 and 7, so 7 will be exclusive of it, and you were giving the array size as 2 by 3. So that is how it is actually given here. And this is one random number is generated here. So when you run this, you are getting 6. Again when you are running this, you are getting 4. Again you are running this, you are getting some other numbers. See here, so every time when you run it, this values actually differs. So this is what you want to keep in mind. Now when you consider the seed is very important factor, as I said. So seed means you are setting a starting number. Okay, so normally when you look at all this, random int and rand and all, it actually uses a deterministic algorithm. So it is not like that complete random, but it's using a deterministic algorithm which actually generates set of numbers, but random in a random order, that's all. But if you set the seed, what happens is that it will set that initial, the starting point. Okay, and say, just imagine I'm just taking this off as of now, I'm just cutting this out. Okay, and I'm going to run this one. Okay, you are getting this value, right? I am again running this, you are getting the same value. Again you are running this, you are getting the same value. You're getting my point? So every time you run, you get the same output. So now here it is again 0, 10 and size is equal to 3. So when you look at it, I am getting the same values 4, 6, 9 every time. So why? Because I have actually set the seed. Now I'm just hiding this seed, and I'm trying, I'm getting some other number, and again I'm trying, I'm getting some other numbers, again I'm trying, I'm getting some other numbers. So this is the beauty of the seed. So why it is actually important, actually I have actually given it here also for your reference for later. You can try this also. Because in most of the algorithms, the simulations and ML models, we often need the results to be repeatable. Then only, that's why, without fixing the seed, it will just give you very different results every time. So that might not be actually possible. So when you set the seed with the starting point, it will make sure that your results can be reproduced. Okay, so that's the beauty of the random dot seed. Okay, that's very important. So now actually in this what we have done is that the initial part, what we have done is that we have actually learned about the NumPy. It's a very powerful package. It's numerical Python. It has got various functions actually inside that, and each and every function actually has got can be applied upon 1D array and multidimensional array, and you can do broadcasting upon the arrays of different sizes. That is actually possible. So it will actually automatically pad, and it will get these things done. And there is vectorized operations where all the arithmetic operations will be performed all at once, element wise, on the arrays. And you have also got this random generations like rand int and seed, right? So this is what we have seen, and we will see pandas in the next video. Thanks a lot. Hope you understood, and if you have any confusions or doubts, always let me know. Okay, thanks a lot.